Good evening once again. Happy Sunday. So we are going to pick up from where we left things yesterday. The plan I have today is to go briefly what we covered yesterday and then build on top of that. And the key thing today will be to extend the solution to cover the Java side of things. So we have we're able to implement what we have in our design. I think currently now we've got things to the point where we are able to get the front end to speak to the back end, the Python back end. So we will try to extend that to cover the Java bit. So without much ado, let us get to work. So I'm going to take us a little bit back to the design document, so to speak. So let's do GitHub, template, that one. So this is what we're trying to basically bring to life. Essentially, what we have is we are trying to implement a two-tier system whereby we have, a front-end system which is speaking to back-end system in a way. I want to do such that we put redundancy in place whereby we have a replica of the machine across availability zone just to make sure that redundancy is there in case we lose a node or we lose a data center, we don't basically have service being unavailable. But we've kind of started small. We kind of, first of all, went through the journey of provisioning one machine for the front end and another single machine for the back end. And then we went through the journey of how a developer will build the application that would eventually get deployed on the front end and the back end system. And what we were able to achieve yesterday was to show us how a developer will start his journey doing the work on his own local laptop and doing his tests locally, and then progress the work basically pushing his code into a repository such as GitHub, which is what we have here essentially. A source control system, that was what I was looking for. So a source control system such as GitHub, which is where he would push his code. We deliberately went through that journey, showing us how a developer will start, the web stuff, writing the web code, and obviously also doing the Python bit, etc. Okay, and the guy tested, so to speak, on his local laptop and then pushed the code up. So we then looked at the part where the DevOps resource would go through the README document of the repo to kind of familiarize himself with what he needs to do to get this application running on a proper virtual machine system, in this case on the cloud. So then we chose to use infrastructure as a service approach, whereby we spin up a VM, a couple of VMs, and then condition them as a web server or an app server. On the first node, we install, because based on the requirement we were given, we needed to install Nginx HTTPD on the front-end system, and then we needed to install Git on the front-end system. The Git was to allow us to be able to download this repo on this machine. So after that, we kind of, took care of the front-end system, got Git installed, got Nginx installed, then we downloaded the code, and then we moved the file around on the web server to basically configure this web front end, which we see here. So there was the web front end that got deployed. Yeah, and then we looked at the Python bit, which is the backend system. And in that case, we tried to spin up a machine. Fortunately for us, see some noise there.
Normally,
Trying to find the person distract now.
iPhone 18. iPhone 18.
iPhone
How do you
18.
come out of? Oh, just do Control C.
Control C, right? I've lost control now.
Oh my God.
Yeah. Pardon, I'm trying to find the person. Okay, maybe it's gone quiet. And I think there's a way to kind of auto set it so everyone mute. So I will look into that. Apologies. Kind of knocked me up a little bit. Okay, cool. So, all right. So where was I? So the Python bit, obviously, then we install that and configure it based on what the instruction the given instruction from the developer in terms of what we need to do to have it configured. One thing we mentioned was when applications communicate, they communicate through a window or port. You have to know the port through which a communication would happen. For example, if the web server needs to talk to the app server, they have to agree on a port where the app server will be supplying whatever it needs to give to the web server. In this case, the app server will supply fruits information, fruit data to the front end. The front end needs to know the port through which the communication will happen. In this case, we said we chose port 9000, which is the port where the app server would run its stuff from which the web server can extract the data it needs. The port is a window through which systems will communicate. So, and we say for that to work, the application must run on that port, which is the application on the Python app, on the Python VM, has to specify that port when it's running. And also we need to ensure that at security level, we open that port at VM level, which is something we do in security groups to ensure that at VM level, the port is open, and also at application level, the port is available. So you run the app on port 9000, and also you ensure that the security around the VM allows traffic through that port 9000. And then we set both up, and then we're able to get things moving, which is what we have here. So this is the Python bit running. And this is Nginx running. So we usually said we needed to copy the file, into the right location on Nginx to get it working, which we have done before. So we've not really done anything new here. So we were able to obviously get to that point where things run and things work. We had to make a little bit of adjustment. If you recall, we needed to, because the web server needs to speak to the Python code. The web server needs to know the address of the Python machine. And we couldn't know that, ahead of time. So we needed to kind of cheat a little bit by going into the repo, if I can find it, by going into the repo and specifying. So we went into the web code, and then we open up the web XML, and then we say we need to point it to the machine where the Python code runs, because he needs to know, otherwise he won't be able to speak to it. In real life, it's not done this way. But to simplify stuff just for now, this is how we're gonna do it. So, and that will require regular adjustments, sadly, because as you are destroying machine and recreating them, the address will change inevitably. So when you drop a machine and you recreate them, they have new address. So you would then have to go to your web and go, already, you get the new address, and then you will then update it here so that, obviously can be then up to speed as to what the new machine is, etc. So this is where we are. So we are going to pick things up, and obviously we have a running here. So the plan today is to extend this work. Obviously the plan we have was to, and it is still to have fruit list and vegetable list. So we want the fruit list to come from a Python code, and we want the vegetable list to come from a Java code to kind of reflect the design we have in mind. So the Python code would have so we're gonna have Python running on this machine, and then potentially we will install Java on it as well, and then we'll drop the Java code on it. And the Java code is what will give us vegetable list. So before we can do that, the developer needs to go back to the drawing board and extend the front-end design as well as the back-end design to make that possible. The first leg of the design is done and implementation. So the next leg will be to extend this and do some work on the front end and then do some work on the back end. Remember, this is not running from the developer's laptop. This has been deployed as shown here. This is all already in the cloud. That's why we can see it here. The developer doesn't really have business with cloud. We assume that this is live now. The customers are using it. When the developer needs to do his work, he will do his own work locally so that it doesn't interfere with what is happening here. Okay, because you don't want to be doing your development work as a developer and then inadvertently breaking live system, which is what customers will be using. Developer then is informed that, oh, this version 1 is live and is working and everybody's happy, but we want version 2 because we are only showcasing fruit information. We want you to update the code to do vegetables so that we can deploy that and our customer can see the price listing for fruit as well as vegetable. So then developer will then go back to drawing board and say, okay, all right, let me look at, so again, I'm going to play the role of developer here. So you're going to see what it's going to do to extend this, and then we're going to deploy again as well. Or whatever we're doing, bear in mind that we are only doing one leg. We're not even looking at the blue side. We deployed one Apache web server, deployed one Python endpoint as well, Python VM as well. And in terms of visual, we can look at it here. You can just go and look at the virtual machines we created, the web, and the Python backend Python backend. Let's call it Python. And this is going to change that, but we're going to try and put Java on it at some point. Let's just leave it as such, Python backend, then call this maybe, let's call it front end. Okay, so let's leave it as this, and then, yeah, this is what we've got. And this is where the Apache web thing, the Nginx is running, which is this machine. If you want to connect to it, I can send that to you so we can both check things in real time. This one is this fruits endpoint. I'm using the IP address. I could use the name. So this is the IP address. This is the net. This is the IP address 67, and the name is that. You look at it here, 67. It's the same thing as using HTTP. The name is still the same. You get the same thing, load. And we said that this load fruit information is obviously coming from the Python bit, and that is this other machine, which is the Python backend. Okay, and we did say that the Python backend, which is a VM, has to be open up on the port where you would supply the information that the front end needs, the backend needs to be opened up at the port where the front end needs to extract data from. So in this case, we are specifying port 9000 for the Python code or the Python app. So that means at VM level, at the virtual machine level, you need to first and foremost open that port. And that is why you go to security, look at the security group, you launch it, and this is what I've done here. If you close this port, then you will not, the communication won't happen. So that that port has to be open. Doesn't mean it would work. And it doesn't mean, it doesn't mean it would work. You have to run the application itself so that it can serve on that port. but you need to expose the pot first. Otherwise, even when you're serving and the pot is not opening, is not open, it won't work. So the way I kind of explain this to people that they better understand it is, a system is almost like it's like a big house where there's a lot of cooking going on. So if you look at it, think of a virtual machine, a machine as a very, very big house with little kitchens where people cook. So let's say maybe in that big house, there is Chinese cuisine, there is Nigerian cuisine, there is Sudanese cuisine, and there is Western cuisine. So Chinese, Indian, African, African, Western, different cuisines. So depending on what you want to eat, you will know which kitchen to go to. So every kitchen has a window. So if you want to have a bite of Indian masala, you know you have to go to the Indian window. So you queue at the window and then somebody serves you from within the kitchen, you're outside. So they open a window and they will serve you. Okay, because they are the server, right? If you want to have Nigerian cuisine, you go and queue outside at the Nigerian window. It's a big house, but different windows. You queue at the Nigerian window, and from inside, they will give you your eba or your apple or whatever else they are serving from Nigerian cuisine. So it's a window. But the first thing is that window, even if they are cooking delicious eba, in the Nigerian kitchen or the Yoruba kitchen, if that window is closed, even though the food is cooked, you still won't be able to get to it. So the window has to be open first. That's the window opening. Okay, there's a service running here. So this can be your eba service. This is your Indian cuisine service. So somebody else is cooking something here on the same machine. Somebody else is cooking something here. So depending on what you want to eat, you go to the window that kind of suits you. But you have to open up the window first. So now in this same analogy we are using, so even if a window is open, okay, you go to Nigeria with the Yoruba window and the window is open, but there's nobody in the kitchen cooking. You're just going to queue there forever because there's not going to be any food. So the fact you open the pot does not mean things will work. There should be an application of this. Some cook here cooking. If the window is open and there's no cook cooking, it won't work. So let's say now in this case, window is open, right? And then who wants to eat the food? Let's say I want to eat the food. Let's say this window, see, using the same analogy. The window is your Yoruba Eba window, right? And then the window is open and I want to eat. What are they cooking here? They are serving fruits here. They're just serving fruit. So I want to have some fruit. So I know that this machine, they're serving fruit on port 9000, window 9000. So I go and find the machine. It's this machine, blah, 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 the back end, which is this machine. Okay. I know on that machine, it's TP, this location, and window 9000. If you don't specify the window, you're gonna miss it. And I want some fruits. And this is where you're getting the fruit from. If you go to the wrong window, you're on your own. So let's say you go to window 8000. There's nothing happening on that window. You're just gonna queue forever. You're gonna just be looking. You're gonna go hungry. They're gonna open until the nighttime comes and then nothing happens. You can see it's stuck. It's stuck because that port is not enabled. So the window is shut. So the window where things is happening, at least as far as fruit cooking is concerned, fruit serving is concerned, is 9000. And that's why you have to go to 9000. This 8000 is the wrong window. So now it's timed out. So it's not happening. So you go to window 9000. And Bob is your uncle. Okay, but we said that, for that to happen, there has to be that window must be open. There has to be cooking or some serving going on. So this is the first leg. The window must be open. Yeah, we fulfill that part. Okay, window is open. And then we can also then say that there has to be some serving going on, and which is this other bit. The code has to be serving. That's the Python code is serving. See, I am serving on port 9000. It's actively serving. If I stop the app, now the app is stopped. So it's no longer serving on that port. If you go here and check, now I want some fruits. Yeah, the window is open, but nobody is serving. And then obviously that then affect the front end because this front end is feeding off this as well. This front end will now not work. It would break. You can see load fail. If you refresh and then you load that, it will not work because the window is open, but nobody is serving there. So we need to call the server to serve. And that is what you're doing here. If you're serving on the wrong port on the system, yes, you are cooking. So if you do the wrong port here, yes, you're cooking. I mean, the fruit is being done, but people are keying on the wrong window, and that window 8000 you specify is not available. The system configuration, you have been given 9000, so you are cooking in the wrong kitchen, and the people looking for you are looking for you in 9000, but you're on 8000. So there's a mismatch, and it still won't work. So you go here, it still would fail. So there has to be some understanding around where the cooking is happening and where people expect the cooking to be happening. So there's a mismatch here, obviously, in this case. So you need to cook in the right kitchen and open the right window, and then we're good. So this guy is all cooking now, and we're all good. Right, so if you then go back here and then you load fruits and everybody is happy. So this front end is feeding off this back end. And that's what we're doing with the Python code. Of course, we can extend it and add some other fruit items, which we're going to do now, etc. More importantly, we will look at adding vegetable items and stuff. A lot of things I'm sort of not they're really talking about right now. So in terms of what localhost is, what this actually mean, and why would you use this and that. So I don't want to kind of give us information overload just yet. But as we progress through the program, we are going to be talking about so many of these little details because they actually have significant impact on how the overall system works. So if you kind of notice that I'm not talking about something that you think are deemed important, it's deliberate. It's just also not to give us information overload. All right, so this is all good. And then the developer says, okay, I've looked at it. And then it goes and look at the repo. And then it's okay, the repo is good. And probably notice that they are playing with the index.html because they are trying to make it work for them. And then I say, okay, all right. What the developer is going to do is this. Rather than say, okay, I want to create a version 2, right? So what it does is the developer will probably create a new branch so that it doesn't interfere with what is happening in the main branch. We create a new branch, and then we can call it version 2. And then it's going to copy all the code from main branch into version 2. So you will then create the branch. Let's go version 2 now. So if you then go back to fruits and veg, you've got 2 branches, main branch and version 2 branch. Okay. So whenever he wants to do his work now, because he doesn't want to basically change whatever is going on in main branch because he doesn't know who is doing what, but he needs to do his own work. He doesn't want to interfere with other people's work. So he will create his own branch called main branch, and he will try to download from main branch and then get in the system. So what he's going to do is he will go to his system. So this is the cloud, and this is the DevOps guy's world. Or the developer goes to his own world, so which is here. It's gonna clear the screen. And then what he's gonna do is he will try to download the code and then just bear with me. Okay, so the developer will come and then find a convenient spot in his system on his system. Let me just do it. Let me go to temp. Let me make a directory. Class 8. See, this is class 8. So it's probably will work from here. So the developer will then do git clone. It will clone the repo here, paste. I don't have it copied, so clone because it will be updating. It will clone as a git, no HTTP. Clone as an SSH git, and then let's do that again. Git clone. I'll paste that, and then it will then check, and then go into fruits and veg. Okay, or just actually let me just stay here. So whatever I'm doing here, this is the developer. Don't worry too much. This is not what you would do. This is what the developer does. So there's a couple of things I'm going to be doing. It don't really matter for the DevOps guide, as it were. This is developer kind of playing his own world. So whatever I'm doing now, at least for the next 15-20 minutes, don't worry too much about it. So I'm going to launch code. So code is loaded. So I go fruits and veg. Just gonna close that out. Go here. I probably will take all this out. And I will divide my screen up so I can have the command line. Okay, I'll go into fruits and veg. I've got the Python, the web, and then I'm gonna look at the branch where I'm operating from. I don't want to do it from main. I want to do it from version 2. So I'm switching to that branch because that is the branch I want to use. I want to effect. I don't want to change what is the main branch just yet. So because I'm going to be playing with this and I want to be able to do whatever I want on this branch without interfering with what is in the main branch. Just a copy of the other branch so that you can simply do things without interfering with the other branch. So first and foremost, I've noticed that they have updated this just to make you work on their system. This has been changed. Okay, and probably that's the only thing. So it's just a hack they've done to point the web to talk to the Python. This is where they deploy the Python code. All right. So developer needs to kind of prepare his own local environment to get things working. So he probably might change this to localhost again, blah blah blah, to kind of get things to where they were. So he probably will redeploy this on his local machine to kind of just set to reset things for him locally so that he knows that, okay, things are working the way he basically want them to work, essentially. So let's see what the developer would do now to kind of prepare his own local environment. So forget about what is happening on the cloud now, which is all these, sweet stuff. He needs to kind of get back to local hosts, etc. So remember, for him, it's still going to be the browser. So he has local host, which is what we did yesterday. Local host. Okay. So it's still kind of showing. Okay. Local host. And then I think it's called share something. What is it? Local host. Schools. Local hosts. Let me see. Let me set that. Again, don't worry about what is happening on my system. My system is a bit. So let me check what it looks like. Local. At the top. School website. That's how I call it, which is strange. Okay. See. Let me set this up real quick. Bear with me. So CD. This is all my local machine, so don't worry. This is the developer just trying to get the system in order. It doesn't affect what is happening, what is already deployed for customers. So the customer probably continues to use the application, but the developer is trying to do a version 2. So the developer is just preparing a system, and this happens a lot. They need to kind of get their thing working, etc. So let me see, what have I done? Cat index.html. Okay. All right. And then see the school website within there. Okay, everything's a bit all over the place. I'm just probably need to do a little cleanup of my local environment because there's too many things deployed everywhere. And I can't seem to figure out. Okay, cool. So let me first and foremost try to restart because I'm on a Mac machine. There are going to be things I'm doing that it won't make sense to you. Please just ignore. Root service, restart Nginx. This is how you restart it on a Mac machine. Just want to make sure that things are nice and clean first. And just to okay. Services, sorry. All right, okay. So Nginx is restarted. It's good. Okay, it's now behaving nicely now. So if I launched it, because this is on my local machine, I have not updated anything. So this probably won't work, okay? Because I have the old index file on my system. What do I mean? So this file is currently deployed in my local Nginx, and if you open the file up, you will see that I'm pointing to localhost. So I need to fire up my system so that the Python now begins to work on in localhost, and then now obviously this front end can then pick it up. This is localhost. This is my local machine. It's different to what is happening on the cloud, which is what the DevOps guys are asked on. This is the developer trying to kind of get the version 2 working. So he's trying to prepare a system. You then say, okay, all right, the web works. So probably it's seen what they've done. So he has not pushed this. If he pushes what the DevOps guide implemented in terms of this index file, if he pushes into his own local Nginx system, it would work, but it would be pointing to production fruit machine from his own local machine. Because now the new code is downloaded, it's reflecting, it's basically saying consume from the web, from the production deployment, which is where the fruit is running. Ideally, the developer doesn't want to be pointing this code to production because he's just doing his own local thing. But he can mistakenly do that because he has the code here. If he deploys this code into his own Nginx local, because the code he has in his Nginx was the code he had like yesterday, whatever. So now if he deploys this code into his Nginx local, you will see that this localhost will probably work. But it will mean that this local will be pointing, even though it's running local, it will be pointing to the fruit machine in production. It will be like you're running something local, but you are actually getting the fruit information from the web, from the internet or the VM instance on the internet. The developer ideally shouldn't be pointing to a production system when it's doing its work. So let's kind of show that, which is something that often happens actually. And maybe a few classes from now, we're going to see how to mitigate that. The developer then has his code here. So it would then say, okay, right. This is what I've downloaded. I'm in my version 2 branch. I'm going to deploy this web into my local and then see what happens. So it would then say, okay, I want to copy sudo copy cp, so it's here, ls, cd into web. Sorry, let's seed into fruit and veg on this local machine, seed into web. That's it. And I will copy index into USR, local. Remember, this is all on my local machine, so you probably won't see this. I think school portal. This doesn't really matter. This is just how my system is set up. Okay, so now is copy the file into its own local Nginx. So now if you still on my local Nginx, if I cut the file now because it's there now, it will be different because now the file has been pushed to its Nginx local. Now before it was localhost. Now, after downloading the latest repo and pushing the Nginx, the index file to its Nginx, it's pointing to this. So now it's inadvertently pointing to production on his own local machine. So if he refreshes this localhost, it would work. And it doesn't. Okay, let's see why it doesn't. Okay. Let me do a restart. It should work because it's pointing to. Right. That's interesting. It's just an experimentation, but I wanted to show you that so that to just cement our understanding of how all these things kind of connect. But let me see why it's not working. Bear with me. I'm gonna launch it from. I'm gonna use Chrome. Chrome helps us to understand things better. So I'm going to bring Chrome just here. I would then say localhost, and then fruit doesn't load. So we would say we want to inspect. And then we go to network and then have a look at what is going on. So we'll then click and then see it's pending because it's trying to reach this chat. So let's see, is this chat accessible? Okay, for some reason this chat is not accessible, which is good. So let's see what is happening there. It looks like our Python code doesn't work anymore. Oh no, because obviously this is correct. Because what we had here yesterday was the old machine VM that we provisioned yesterday, which we haven't updated. So that's why it's kind of stalling. You can see this is an old machine name that we created yesterday, still in the code. So this machine does not exist, 252 machine, and that's why it's stalling. So that's what do I mean? So the code is reflecting a machine that's already dead. So we don't have a 252 machine. The new machine we have, the only place where the backend is working now is this one. Okay. So let's go back. Instances. Let me make sure I get it. So the backend is running on this backend machine. If you copy it, and developer puts the right machines there. This machine is dead. This was yesterday's machine. And put that there. That's the new machine. And then it does the copy again to push it into his own local Nginx. Then it should just work. So the one that is stalling now should no longer stall. So refresh and then load, and then it works because it's now pointing to the new, and then it's from his local machine. That means his web local is pointing to production backend. So if you want to kind of reflect that in the design, it's your local machine is pointing to a VM instance of the backend. Ideally, the developer should not be doing that. It should just kind of get his own local thing working and point it to it so that he can do his own local work. So which we are going to do? So developer then say, okay, I shouldn't be pointing to production system. That's not ideal. So let me correct it. It will quickly revert to localhost. Of course, nothing is running on port 9000 local yet now, but at least it will revert and it will expect his local test to break, refresh, break, okay? And that's a good starting point. And then it will say, okay, now let me start my Python stuff. And he goes to his Python stuff. and then it continues from there. So I will back up to ls and then a cd to Python, and that's where we are, which is this one. Okay, so we'll then fire up this Python application, and then it will do all the necessary rituals to get Python working. So let's clear the screen, and to get Python working, it will do I think I need to do my own exports. Please don't worry about this. It's just how my system is set up. So we then say Python 3 minus m v and v e and v and v. I explained all this yesterday. And then you would do source. We'll do source. Source.v and v in activate. Let's just get things set on. If that is to set up is that is basically to set up is the Python virtual environment. Good to go. And then it would do Python just to check the version to make sure we're good, the dash version. That's good. And the next thing we do is Python -m quick install -r, install all the binaries requirements. And now we just install everything in this virtual Python virtual environment. And now this is good now. So the next thing it then needs to do is just to start it up. So just a UV icon. And then it will say main app. And then it will specify the ports. You see, I'm not specifying host because it's my local host. I can get away with that. I can just specify the port. I can choose any port I want. It's my local machine. I'm going to choose 9000. Everything is happening local on one machine. And then reload. And then that should be it. And then it should just work. Yep. And now with this now, we're serving from our local machine. And this should work now. And it works. So we've now removed. So this is working independently of this. I'm going to be seeing those changes very soon now. Load. Yeah, this is production, and this is the dev guys system. Somebody's asking a question. Sorry. Please, can you explain more the VMV? Yeah, let's not. Okay, I'm just going to explain it quickly. I don't want us to dwell on it because it's not a Python class. So the VMV is so. The way that works is the idea is to ensure that when you have many Python versions, so let's say you're on your system, maybe you are doing Python version 3.1, version 3.11, version 3.9, you might have different versions of Python. And with Python, you need to install different libraries because maybe you are doing a design for project 1, project 2, different projects. When you install libraries, the libraries go into one big repo on your machine. And when you're working on different projects, you could have library conflicts because maybe those projects require different versions of Python. So what Python is now saying is we can enable you to create a virtual Python environment. This is not a VM. So this is a virtual environment within Python itself. So what this is doing is you are setting up this project will not, any deployment that is happening, that installation that is happening, it is not happening at kind of your machine level install. It is virtual, it is Python virtual environment level install. By the time this is all done and cleaned up, all this installation will just disappear. So it is not interfering with your underlying system. It's just to protect or contain what you are doing without so that there's not any interference. It's just a clean way of using Python. If you're interested in seeing what is in a VMV file, I can just show you. So anyway, just bear with me. I don't want to go here. So if you look at the VMV file, then we go in there, you see all the stuff. See all the installation we're doing there, they all sit there. And then you can look at the activate script. Activate dot CSH, and then you can look at the codes if you are interested to see what it's doing. When we call the activate, this is what is happening, but you can have a look. So that's in a nutshell. It's just to create a virtual environment for your Python code. So let's clear that. All right, so now we've got this working now. Bear with me. Okay, yep. So we can just for good measure, we can try to separate this and make it a little bit better. So we'll go here, the index file, and then we will do something like this. We'll just say new fruit list. Let's do that and just say new fruits. No, let's just say, let's call it new fruit list. Okay. And then load, and then let's add so this is the new fruit list, and then we can deploy that real quick, and then we can also then add some information to the Python list. So before I even deploy the fruit list, so let's look at the Python code and let's add some new fruits so that I will just reflect. We're gonna deploy the new fruit list, but before we do that, let's just add some interesting new fruits to the list. So here we just basically just do a copy. Let's do a copy here. Let's do paste. And then we go banana cherry. So we're gonna get maybe orange. And let's say the price is 1.8. Let's get black blackberry and
Blueberry.
blueberry. See, blueberry. So, and then let's get
Blackberry.
lime. Okay, yeah, let's get just lime, and then let's 5.5. Yeah, it's just adding a few things here and there, really, to be honest, and that should do it. Because this is all kind of working, and that should just automatically reflect. Let's see. Load fruits. You can see now our list is growing, but the guys in production, they don't see it because it's not been deployed. This is all local. I'm adding new version, and then it's done some new fruit lists, but he hasn't deployed that website of things. So he's updated his stuff to say new fruit list, so we can deploy that as well. So you would then go here, and then we'll do the copy again. Sorry, let me do the copy from here. Go back one step to web. Again, what I'm doing, if you don't understand it, this is just the developer doing what he needs to do. CP. I'm going to copy this index file and I'm going to drop into my local Nginx. That will then show new fruit list. This is fruit list. Then you refresh that. You're going to have new fruit list and click on it. So there has to be some deployment of the web. The application is able to pick it up locally itself, and it's all going good and swimmingly. Fantastic. Now, the developer wants to step up a little bit and then do the Java bit. And then you want to say, okay, I want to now basically have the site that basically does the vegetable part as well. Not just the fruit part. I want to do fruits and vegetables. And I want to bring down board, etc. Blah blah blah. So the need to do that, you will need to update is the front end to reflect fruits and veg. So I have a template. I'm going to load it. I'm going to walk us through a little bit what it means, and then we'll just take it from there. Because I don't want to hack this too much. So I have a template so that because it might quickly get a bit wonky. Actually, let's see if we can do it together. I don't want us to make it a troubleshooting class. I'm maybe worried because sometimes you have a good plan, but yeah, so I have a template. I'm not going to use it, Or let's just kind of play with it for about 5 minutes. If it's broken, then I will use my templates. But I just want to show us how this will just slowly change. Slowly change. So what we have here, if you look at the table here, so if this is too much for you, just when you're watching this video, just this or this coding bit, because I don't want to scare people with coding. It's easier than you think. When we start using AI, you will see how easy it is to kind of get all these things done. But now, because we're not using AI, yeah, it might look a bit daunting, but it's not as hard as it seems. AI has actually leveled the playing field, well, as far as coding is concerned. So there are a few things you can kind of just about pick up here. So for example, you have a fruit list. If you're doing vegetable list, it's very easy. You could just like basically do a copy. And then you can do like a paste. I'm going to use my template, but I want to show you what it looks like first before I use my template. So you can then say maybe new vegetable. Vegetable. And then you can call this like load veg. Load veg. Then you can say load vegetables, something like that. And then you can call it vegetable table. Like that. And I can say vegetables, rice. Essentially, this is what it's going to look like. Of course, the vegetable will not work because now when you click on load fruit, so this is the new, say, click on load fruit, click on load fruit button. So this is ID. This is how it basically would, so the click on button, load fruit, would call this endpoint, which is where it gets all the information from. And then it will just load fruit, etc. And then it will just create that, it will just create that, build that table for you. And this is what is happening. So whenever you click on that, they load fruit. So if you look here, so there's a script. When you click on the load fruit, see that? Click on load fruit. So which is load fruit. It will go and so this is API, which is the fruit endpoint. It goes to load fruit. It will use the API to fetch, and then we'll fetch and load. So we can just basically copy this. So the load fruit, the vegetable, and the way the developer works is they work one step at a time. So for the vegetable, you probably will just load fruit for now, but even for the vegetable, because you have not done any vegetable work. But just to kind of keep the design going, it was okay, for vegetable, what do I do? Okay, I don't have load vegetable, blah, blah, blah. So there's an element called load fruit, which is when that is clicked, it calls this. The vegetable is saying the ID, the button should be load veg, but there's nothing that is going to happen when you load veg, because there's no script that gets called when the load veg is called. But the first step is at least you're making progress using doing the design. This would not work, it would look a bit silly, but then all the same, so let's call this the output 2, just to separate things out. So, but now when you call this, nothing happens, but at least you see something on the front. And so the developer does this first, just one step at a time. And then he would do the copy again. And then it will test. You can see load vegetable, load fruit still works. Load vegetable obviously doesn't. Okay. And then it will say, all right, okay, it's a bit, yeah. And then it will say, okay, right, what do I do next? It will probably then duplicate this. So this is the URL for fruit. And then it will say, okay, all right, let me just duplicate this for vegetable. So the load fruit works up to this point. They might just copy this and say, I want to do the vegetable part. So I wouldn't say, okay, for vegetable, I'm going to call load fruit anyway, and just load fruit item into there until I do the vegetable. They just want to make sure that it's working okay. So it will say, okay, yeah, when I call this ID should be called load fruit as well, so that when you hit this, it probably should call this. And then okay, I'm gonna test this out and I'm going to try that. So bear with me. So then does the copy. It's just a little bit of a hack. Refresh. I'm gonna play with this for a bit and then I will. Okay. This is because this is not outputs S CP refresh load. Okay, still doesn't load. Right, I don't want to make it like a troubleshooting session. It's not as hard as you think. So I have a template. I'm gonna copy it and I will explain it because I already worked on this. I don't like to do this in real time because it's not hard, but it takes time to troubleshoot. So I'm gonna bring this here. Hopefully I won't worsen the situation. So I've kind of created some things. I'm gonna change a few things. So vegetable list, fruit list, I'm gonna do this and look at list. Gonna do 9,000. Vegetable list won't work for now, which is fine. So this is the template I created a while ago.
The local host, you're missing, I think you're missing O.
I'm missing, oh, thank you very much, sir. HOST, thank you. This one is, let's change this to local host as well. Local host. We know the 8080 doesn't end. There's nothing running there. So this will be Java's blah blah blah, which is fine. And let's save this. At least the I hope I haven't broken these fruit ones. So let's see. Refresh. So load fruit works, load vegetable doesn't work. So we're good. So load fruit still works, load vegetable doesn't work. Okay, so let's change this to reflect what we have. It's not produce list, so let's call it fruit fast API, vegetable fast API. Okay, Java. Okay, cool. So now we're good. It's still kind of cool. Well, the vegetable is the Java part. So we're kind of there now. The fruit is good, vegetable is not. So we then need to then begin the Java work now. So we kind of got the system to where it should be. The front end design is there. The Python bit is singing. The web bit is singing. The only problem is we don't have a Java kind of kitchen to cook out the vegetable meal, which is what we're gonna kind of get into now to get the Java bit essentially working. So Java is just another programming language that we need to get our head into. So as a developer, you just kind of get into it and then basically create your Java environment and all you have to do, etc. To kind of get things working. So if I was doing this, so I'm gonna kind of freestyle a few things. Please bear with me if it goes wrong. I'll try as much to correct it. So it's a developer again. So it's done the Python and the web and the rest of it. Then we'll create a new folder for its Java. Let's say Java. That's the folder. So in Java, so there are a couple of subfolders I need to create, just the way Java works, essentially. So for Java to work, you need to have at least two things running on Java. You need a Java virtual machine. So you have to, as a developer, you need to have Java running on this machine. It probably needs a sort of like a packaging tool such as Maven to kind of get to be able to compile and get his Java code compile running and working on his own local machine. You probably would need Maven for that, and a few other things that Java guy only needs to worry about, not the DevOps guy. So the Java guy gets to work, and probably write a Java code. So the Java code will be, I'm going to create a couple of folders. I think it makes sense to use the command line to create it. So I'm going to go here. I'm going to back one step. I'm going to cd to Java. ls minus ltr. There's nothing. Now cd. Where's the Java? I think I put it in the wrong place. Oh yeah. So it should be floating veg. Java should be in the project. So yeah. So it's down your ls. You then have Java, Python, web. Okay. So in Java, let me clear my screen. So I'm gonna make a directory. I'm gonna make mkdir src. So mkdir minus p src. This is me just freestyling main resource. Is the resources main? Oh, right. I'm gonna have to look this up. Bear with me. Let me check. Maybe Java folder structure. Structure. Okay. Okay, I think I'm about correct. Main Java. And that's it. So I'm going to create this directory structure that just says source main Java. So that will just create those directory structure for me. I think I've done it in the wrong place. Bear with me. So rm-fr, let me clean up. So I've created this directory structure source main Java. I've not done it well, so let me just remove it. So I need to be in Java, which is here. And I'm going to create that directory. Those directory actually, mkdir minus p. What this is saying, just for everyone's benefit. Sometimes you need to create 3-level folders. Source, main, Java. Maybe in here, I want to create 3 directories, which is source and a subdirectory main and another subdirectory Java. To do that, and this is all Java, don't worry, this is just developer doing as well. To do that in one go, you have to do minus p because it will create this, then create it, then create. If you don't specify minus p, it would fail. But specify minus p, you would then create all those top level and updo it to the last one. That's why you will use minus p. So if you go in here now, you can see source main Java. So in the Java directory now, so I can go in there now. So in the Java directory, I want to create another subfolder called, just for this project, I'll probably do a package, maybe com example or whatever we can make up. I'm just going to make up something just to simplify the code a little bit. Yeah, that's what we're going to do. So in here, I'm going to cd to source main Java. That's the directory. In there, I'm going to make another directory. I'm going to call it com slash, let's call it example slash vegetable. Or let's call it com produce vegetables, something like that. Let's call it that. Okay. All right, so we call this that. And then in here now we have that sub-label. So that's what we've created. So when we go to this, let's expand this now, vegetable. So that's the folder structure, Java, source, main, Java, com. This is all developer stuff, so don't worry about it. So in here, the developer will then basically begin to write his code. So let's call this. So in here, we then create a file. We'll probably call the file, let's call it produce app. Produce app.java. That's the Java code, and that Java code is ls cd here, just to check produce vegetables. If I can see the file, which is this file. So you would then look at it. Okay, now then we'll begin to write the code itself. So I'm just gonna gloss over the code. I'm gonna copy it because I don't want to delay it too much. I have a template. I'm gonna make a few changes. So this is not a programming class. Yes, here anyone is interested in Java, I can recommend Mr. Ahmed is on this call. So if you want to learn Java, Ahmed probably can help you. But it's not a Java class. So com produce vegetables. So let's call this com produce. Produce. Let me just change this a little bit. Vegetables. Vegetables. Yep. As the package import all this. Right. Okay, produce up. Yep. I think it's getting close to what I want. Okay, right. Okay, this is close enough. So what I then need to do is in here, in my source, this is Java, go back here. I need to create a POM file. Okay, source. Very good. Yeah. Java. I will create a file. I'm going to create a file. I'm going to say touch.xml. Okay, in Java. There's a pom.xml file. So this file is like a configuration file, almost like your requirement file for your what's it called, for your Python, but this is just the Java side of things. So all I want to do is just set up that file and then try to run it locally. Okay, I need to tame this a little bit. It's a bit wild. So this is the template. So the basis is com dot. So the code is, I'm using com produce. I need to change that to com produce. Produce. Can produce app is the app snapshot. Blah blah blah. Com dot produces the group. Yep. I think that is about what I need. But we're gonna find out shortly if it's enough. WD. Okay. Right. So I may have got this in the wrong location. Nice. So let me move this. Okay, this is what it should be. So the POM file and the source file. So this is the code in a way, and the developer then begins to kind of test the code and make sure it's all working nicely. So you would use a tool called Maven. Maven is a packaging tool. In fact, it's a very, very, what's the word? It's an utility within that helps you to do a lot of things in Java. So I would then use Maven to kind of test things out a little bit and to make sure that things are working. So I'm gonna do Maven. I'll say Spring Boot, and let me just say Maven clean, just to make sure that things are working. Let's clean up stuff. Okay, it's good. So Maven Spring Good. I'm gonna do run. I can type and I'll do conditional. I'll say spring.boot. Spring-boot. I will do the run arguments.
Is this
Say,
boot or this string boot?
don't worry, it's just making sure it's that you're specifying a sort of like environment variable. So Java server dot address. Let's just run it. Let me server dot port maybe. Let's run it on 8080. Yeah, Java is a crazy programming language. It's a bit stressful, but yeah, it's a good kit, but it doesn't always cooperate. So let's find out if this would work. Let me see. So we begin to, okay, there's something doesn't like 21. Let's go find it. So I'm missing a semicolon. 31 to 31. That's true. It's never wrong. And then boom. Nice compiling the code. He likes it actually. So it's all running. So now we've got this running and it's running on port 8080 local, which is what we specified. Okay, we specify when we run it, we say it should run on 8080. So let's test it on local. So we launch this now. We do localhost 8080. Let me see the endpoint I defined here. So we say it should be /vegetables. And then we say /vegetables. Let's see what comes back. Now it's working. So broccoli, tomato, spinach, potato, etc. So that should have automatically that should make this automatically active. If you have set this up correctly, if you load vegetables now, see that? Now it's working because the code is working and we have the service running locally. Of course, we can add some other items. So we can say, let's add something else. Okay, so tomato, any fruits. I'm gonna find something like broccoli. I like broccoli too much. I'm struggling with fruits now. Vegetables now. What vegetable could we had there? I don't know if kiwi is vegetable. Kiwi, maybe it's fruit actually. Actually, let me know. Let me know bother too much. Let's just leave it out as this for now and just keep it simple. So we've got the list. So fruits load, vegetable loads, everything is good, but it's all running locally. Okay. Now, developer is then happy because if he stops his code now, if I stop the Java code, which I have done now, this way this is how I'm getting it to run. If I stop it, then obviously this doesn't work anymore. Load vegetables is crashing. So if you refresh, the vegetable won't work, the fruit still works. So because I've basically stopped the service locally, locally. So it's good, everything works. Now, what I need to do, and this is all developer stuff, don't worry about it. I would need to update my gitignore file to tell the system other things it needs to include because I brought Java in now. There's some things that Java has done that is not useful for me to push into the repo. The developer does all this. You don't have to worry, but I'm doing this because maybe as DevOps people or people that use software, development work is not easy. They do a lot of things that you probably won't know. A lot of tidying up and stuff need to happen for things to work. So the target directory, I don't need it, just for starters. That's one thing I need to go into my ignore file, and I'll say anything target. So this is for the Python bit, and I'll then maybe to the bottom, I'll probably do Java. I'll say Java. So what I'm doing here is, again, all this, don't worry about it. It is not your thing. It's the developer doing his work. I'm showing us this, not to scare us, but to kind of just show us all the things that happen behind the scenes. I'm saying anything target directory should be ignored. Target should be ignored. So if I say git status now, I don't want to see target in there. We can see it's not putting you on top of this. That means it will not take this, which is good. And yeah, and that's it. So I will then basically try to wrap things up. So I will say pwd. I'm gonna go back to the main directory, which is back to fruits, which is class 8 ls. So fruit market. I'm gonna go into fruit, so which is the top directory. So if we kind of collapse this and just close all this out and then go back. So I'm back to the top level. So if I then do git status, so this is the thing that basically added. I'm just gonna do git add everything and then do git status. So these are the things that get pushed. The ignore file has been updated. There's a POM file, there's a source Java file, there's a Python update, there's a web update, all good. Just want to make sure that I have not basically done some damage to my Java code. Okay. All right, look good. Okay. So I'm just going to do git commit -am added Java, added veg list and updated fruits list. Yeah, and then you do git push. So this kind of goes back into version 2, and it's not touching main branch. So all the things I've done here, you can easily fast forward when you are watching the video. You don't need to know about this. All you need to know as a DevOps person is that you have a new version of the code that's been pushed out, which we need to go and fetch. So let's look at it. Let's look at GitHub template fruits and veg. So this is the version 2 that's been pushed, fresh. And you can see that we've got Java now. And that is what we've got. Some vegetable and the produce app. So now our commit, this branch is ahead of the main branch because the main branch still has the old stuff. Because the developer didn't touch the main branch, just kind of created his own branch because this main branch, as it doesn't have Java, the version 2 as code Java, the developer is working off his own branch. So there is no conflict. All right, so we can decide to deploy from branch 2, or the DevOps guy can create his own branch as well, and they say for deployment, so that he can make his own changes as well, because he might need to update what the machine should point to here and there, etc. Which we are going to do. So let's say the DevOps guy now sees the developer stuff and say, oh, there's a version 2, okay? And they'll say, okay, all right. He probably would create his own branch as well, just for release purpose. So he goes into branches. And he said, let me create a new branch. I will do a copy of version 2. I will say version 2 release, version 2 underscore release. Release. And then it's going to create the branch from this version 2 branch. It creates that branch. And then we go branches. Then you have like 3 branches now, right? So, so version 2 release is just a copy of version 2, but the DevOps guy knows he would make some changes there and there, and he doesn't want to interfere with what the developer is doing, etc. So he's creating his own branch as well. It's just for you kind of see the flow. So the DevOps guy now say, okay, I've seen this. He would then go into his machines. This is production. Things are working in production. But what is in production? Production works. It's not what is in dev, which is what the developer did, right? So you would then need to do all the whatever he needs to do. And when you start doing his deployment, things will break. So he needs to understand what he needs to do first. So if you go back to the design, I want us to understand this thing real good. And for those of people that do not understand this, feel free to grab me. I'm more than happy to go over this with you, maybe midweek. It's not really hard. Watch the video a few times. If you're still not kind of flowing, yes, grab me. I'm more than happy to go by with you. So remember that we are only doing one leg, right? We're not really focusing on the blue side, if you like. We're just looking at one leg. So we have the web, we have the Python, now we have the Java. The Python and the Java will live on the Python and the Java will live on 2 machines. The web will live on 1 machine. So this machine will host our Python code and Java code. There's no reason why you can't separate this into 2 machines, but for simplicity, we're going to use 1 machine. And to make things really, really clear, I'm going to trash everything and we will set up the machine together. Everything, just to kind of reinforce what we've learned. But the plan would be we'll set up a web server on port 80 on the VM. Then we will also set up a backend system. We're not going to call it Python backend. We're just going to call it tier 2 or backend, but that will have Python and Java. Then we install Java on this machine. We'll install Maven on this machine. Python comes by default on Amazon and Linux. If you are playing on the Azure platform and you're using Ubuntu, you will need to install, you use app install to install Python, Java, Maven, and all the rest of it. So Python won't come by default on an Ubuntu system. So if you're like maybe Cynthia, the folks on the Azure platform, you would need to install Python 3. But if you're using Amazon Linux, you won't have to. So without much ado, let's do this. So what I'm going to do, just to kind of help us cement what we've learned, I'm going to trash everything. So this is what we have. I'm going to just click on this, click on that, and I will just destroy the machines. So we'll start everything in one slate so that we would understand this if we do it together one more time. So we have nothing running. If we go to our machine, the one that was happily, jolly giving us stuff now is dead. It won't work again because it will just die because the machine is gone. All right. So we'll start everything from scratch. We're going to do like a version 2 release of our stuff. So let's begin to create the machine. So first and foremost, let us create let's bring all this together so we won't have to be going back and forth. So let's put everything in one place. So let's move this one here. Okay, I'm gonna put this one there. So that's the one. So we're gonna do this. So let's create the Apache web server. Let's use Nginx just to, so that we're not just adding any unnecessary complexity. So we'll launch a new instance. We're gonna call it web. Well, let's call it front end. Front end. Front end. Okay. Everything stays the same. I choose my key. All these are just normal stuff. Because it's the front end system, remember, this is the web front end. It needs to operate on HTTP port 80. So we need to make that port 80 open. That's where it's going to cook the web front end. So that needs to be checked. Have it open. And then we will just start the machine. Okay, we just want to kind of get this to work. We go there. All these ones are basically dead end now. So now we will connect. Connect. This, okay, connect. We should be in very shortly. Yep, so this is the machine. So on this machine, we will install Git and we install Nginx. So we'll do sudo yum install Git, yes. Okay. I don't know what this means, but yeah, something is, yeah, it's doing something. I think it's still being set up. Some setup is still going on. So why that is, let's wait for it to finish. Because of the PID. So this, I think the setup is still going on, and that's why it's waiting. So now start it. Git is installed. We'll do the same for Nginx. Nginx, and that's installed as well. So we've not downloaded anything. We've not done anything special. We can start Nginx just for good measure. Sudo service. I can use service Nginx start. You can see me just changing command every now and again. It's just so this service is an old way of managing services in Linux. These days, you can, instead of service, you can use system control. System. This is the same thing, system CTL. Then you then say the only thing is you have to put it the other way around. Start Nginx. Still the same thing. You can use sudo system nginx start or sudo system control start nginx. So with that, if we get this IP address of the machine or the machine name, the public one though, not the private. So we get that or we get that, we should be good. So if we go here, we launch. Oh, this one's not dead now. So let's use this one. Use HTTP with that. And then we have just a basic welcome to Nginx, blah, 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 which is good. So this is always a already a web server. So then we need to move to the next level. The next level is we'll download the code. So what we want to do is we want to pull the code from Git into our web server. So we're going to pull all this code in here and then we can then deploy the index file. Okay, so we then go back and then we say, let's get the repo. Remember, we are trying to get thing from the release 2 branch. That is very important. So code, copy, and then watch. So we go here, you do git clone, paste that. Okay, sorry, I can't use, because I don't have keys copied, I can't use git, I have to use HTTP. That's important, because it's on the server, and the server doesn't have any key exchange with GitHub, so we use HTTPS, and we'll copy that. Then we'll go here. Right, so it's all cloned up, so we have it there. And then we go inside fruits with ls. Now the problem here is when you clone like that, you are cloning from the main branch. If you say git branch is main. So you need to check out, you need to move into the branch of interest, which is version 2-release. So we have to do git check out. What's it called again? Version 2-release. Version 2-release. Has changed. If you ls now, you see more things because you're in that branch now. And this is where we should work. Okay, so we'll cd to web and ls, and that's the web file. We can copy this index file into the Nginx location, which is USR share Nginx HTML, and that's where it should go. If you try to do this, it's going to say you need to have root access to do it. So, okay, let's do it. That's what it's going to say. So you have to do it with sudo. If you say sudo // if you say sudo // you will execute the command I did before, or you can, or you can just literally just say sudo cp stuff. Yes, Kunle, go for it.
Thank you. Just a quick one. The index file that you're moving, the index file that you're moving, if you look at it, the index file, we moved the first one from the first deployment, the first commit that we have, we moved it. So the second index file that we're moving now, the one that actually contains the vegetables that we've added. So is it the same one that we're changing? Because I know that
okay, this is a brand new system. Kunle, you remember? This is a brand new system. We've destroyed everything. So there's nothing on this machine. Remember, I did trash everything. That's why I wanted to start everything from scratch.
Trash everything and you start.
Yeah. So of course, if it's not the same system, you can just copy and override it. But overwrite it, yeah, that's a brand new system. So
but where I'm actually coming from is that, when we worked on the Python code, we deployed and we moved the index file into the main location, Nginx location, whereby it displays only the Python code section. But this time around, we have the Python and we have the Java. It is still, we've updated the index file to accommodate both the index for, both the endpoint for the Python and the endpoint for Java. So it's the same index.
What's the question? Do you want to wait for me to do it and then you take the question? Maybe I'm going to answer it while I'm doing it. Yeah.
Okay.
All right. So let's do it. And then if you're still not clear after, then you can take it. Because it might be that whatever you want to ask might be something that I would just probably just explain while I'm going through this. Obviously, if it's still not clear after the class, after my stuff, then we can take the question again.
Okay.
Is that okay?
Yeah, it's fine.
Thank you. All right. So we copied the index file to Nginx, and obviously it won't work, but you will see something, because if you look at the index file, we can literally copying what the developer uploaded, which is his localhost. Because you look at the index file, it's pointing to localhost. There's nothing running on, so localhost is local machine. So all this is localhost, vegetable localhost, blah, blah, blah. So, and that is what we are deploying on this machine. And that's how the developer did his stuff on his own local machine, because we are using his repo now, right? And everything is local, because that's how he tested. So, and then we've done the copy. That changes the Nginx. Is it this one? So let's just close. We have too many things open. Okay, so, and now, so what it happens is this machine, let's put this one next to it. So this now, if we refresh this, now you can see now. But the problem is when we start clicking this now, it will just fail. There we go again. I'm lying. Okay, again, it's my problem, because it's pointing to localhost and I have things running exactly what happened yesterday. So let me stop this. We can't fall for the same trick today. So, because it's between localhost, it's pointing to my local machine. So load fruit, that should fail. Load vegetable, this should work normally, because it's just deployed on this cloud system. And the system is looking for things to kind of happen locally, and they're not. And because it's how the developer tested, everything's local on his machine and it worked for him. But when we are deploying, we know everything is not cram on one machine. We are basically separating those machines out. So the web server and the Python code need to operate differently. So the Apache web server should point sorry, the Nginx system should point to the Java and the Python, which is the same machine, but maybe Python running on port 9000 and Java running on port 8080. That's how developers kind of configured it, but he used localhost. We can't use localhost. We need to use the right machine name. In our case, it will be the second machine. So this will not be localhost. This will be second machine. This will be second machine. Okay. So we then go back here. Okay, so what's the second machine? We have not created it, so let's provision the second machine. And that second machine, instances, we'll call it backend. Let's call it backend. Refresh, and then we'll launch new instance. And then we'll call this backend. And this should have Java and all the rest of it. So backend. So same thing, keep it. Master class. I'm not going to change all this port here. We need to open port 8080 for Java and port 9000 for Python. So I'm going to leave it. I'm going to create the machine first and I will update the config. It's easier that way. So we'll launch it. And this will be the backend system. So it's all good now. So we go there, instances. So refresh. So I select backend. Okay, I will then go to security, just to make sure I have those ports open. So I'm going to click on the security wizard. I'll say edit, and I'll add rule for 8080. I'll add rule for 9000. So I'll do the custom TCP, and I will do 8080. Okay, now we have question. Go for it.
The two machines, they are presently on the same availability zone right now. So does that not matter?
I don't want to bring that into it now, otherwise it becomes extremely
All right. Okay.
complicated.
Okay.
Yeah.
Yeah.
I'm
Okay.
just
Okay. All
simplifying
right.
it. Yeah. All right. Any other question? All right, cool. So 8080 custom, and then we say, okay, just make it nice and simple. We are basically very relaxed in terms of how we apply our security, but let's just keep it this way for now. 8080, and then we do 9000 for this is going to be for the so let's say this is for Java and this is for Python, and 9000 for Python, and then nice and easy 00 as well, and then we'll save rule, and then we look good. Okay, cool. So we have those port windows open, and then we go back, go to instances, backend, then we'll connect to it, and then we'll begin our various installations that we need to do to get things moving. So on this machine, we don't need Python. Python is already installed on there. You can do Python 3 -- version. We know it's there. So what we need to do is sudo yum install. We need to install Git, of course. And that hopefully gets installed relatively quickly. Still thinking about it. So that's the first thing we install. Of course, on this machine, we don't need Nginx. This is the backend system. What we need is Python, which is already installed. Then we need Java. So we'll do sudo. I'm going to install Java 17. Yum install install Java 17. Maybe I'll search for it. Let me just try first. Java 17, Amazon Corretto, Amazon Corretto. That's the one I need. So that's the one I need. Okay, that's gone now. So that will be Java installation. And then I'm going to install Maven, which is the tool that tames Java for you. I put this on this machine as well. So while that is ongoing, what we need to do is we then look at this machine. What's the back-end system? The back-end system. So let me install Maven first, and then I'll come to this. So the next thing I want to do is install Maven, sudo yarn install Maven, and then I say yes, and Maven will get installed as well. And then all my installation is complete on the back end. Of course, I've not deployed the code. I've just put on the tools that I'm gonna need to do the work. Yeah, all done. Now, what we're gonna do next is we've now known what the backend system is called. The front-end system needs to be aware of that. So the front, as far as we're concerned, the front-end system is still pointing to localhost. Of course, this is not localhost. This will be the new machine where things are running. So what we need to do is harvest the back-end name, public name, or IP, whichever one works for you. I like name. If I can find it real quick. That's the one. I'm going to get the public DNS of the backend system. I need to feed the front end with that backend information. So I'm just going to cut corners, but in ideal world, you need to develop this version 2 release needs to be downloaded on the DevOps guy's machine, and it needs to update this and put the right stuff there. Because remember, this is his own branch, so whatever it's doing there is not really affecting anymore. But I'm going to just cut corners and do it here. But normally you should download it and do it on a machine and push it back. Just gonna do this, and I'm gonna do that, and then I will commit changes. I will say added backend node name, something like that. Commit change. Yes, I don't know why he's saying that. Okay, cool. So it's there. So now the changes in the repo, but obviously it's not on the machine. It is not on the web. So because if you look at the web, if you cat index, the web is still showing localhost, and that is what is deployed into Nginx. So now the first thing we need to do is we need to take a step back into the main directory. This is on the web, remember, the web machine. So what you need to do to get the latest, you need to pull. You don't need to clone because you're already cloned. You need to pull to get the latest. You then say git pull. So whatever change has been done, you can see the web has been updated, and you say cat just to see index. So now let's cd to web, which is the web folder, and you cut what is in there to see. You can see now that it's reflecting that, and that is what you need to then copy into this. And of course, still not going to fix it because nothing is running there, but that means it's primed. It's good to go now. So if you refresh, it doesn't change anything because it will still just fail and fail. But we are one step closer. So what we then need to do is we're just going to bring in the services to life one after the other. So we'll do first, we need to clone the repo onto the backend system. Same thing, code copy, and then we do a git clone, is that, and then we cd to fruit and veg, and then we ls. Of course, we are looking at the main branch. If you say git branch, still main, so we need to git checkout. I think it's called release whatever, something release 2. Version 2 release, something like that. If you don't know, there's a command you can use. Can you bring -a? It will show you everything on the on the server so you can check. All right, so ls minus RTL. Okay, now in this case, we need to do the Python, the Java, and all the rest of it. So let's go Python, start with, okay? So in Python, we do all those rituals that we should be familiar with by now. So the Python 3 minus mvenv dot venv venv, and then we'll do that. And then we are going to source it as normal. Source dot venv in activate. So what we are doing here is what obviously the DevOps guy would do. So, and then we'll do the Python. And remember, all that has been captured, so we are not just making it up. We don't have information for the Java one, but we can add that as well. And we add that to the repo. So then this is all we are following, essentially. So whatever step that the DevOps guide needs to follow, should have been added to the README file. So the next thing we're then gonna do is we will then sorry, I'm in the wrong place. We will then do Python after sourcing it. Then you can begin to use Python, not Python 3, because you would have prepared your environment and it should just be like that. So let's say Python minus m pip install minus r requirements.txt. That should install everything for you. Comes up what you need. Okay, that looks like it's come back successfully. So we then use UVI kern, and then we'll say you should do the main. Let's see where we are first. Okay, so UVI kern main app. Okay, and I will say host should be 0.0.0.0. That's using the network interface. That's very important in this case. If you're not running off localhost, then say port. It has to match the port we previously configured, which was 9,000, if my memory serves me right. 9,000, and then we'll say reload. Okay, and then we'll run it, and then it's working. I'd like to run this in the background. So I'm going to Control-C to stop. And I will run it, and I will put an ampersand sign in the end. That means running in the background. So I can have control of the console again to do other stuff. Otherwise, we just hang. So if you run with this and then you run, and you can say jobs, you will see what is running in the background. You can see it's running in the background. But that allows you to have access to the console. Otherwise, I will not be able to control the console again because it will just stay here and then you won't have access. If you put the ampersand there, then it's running in the background, you can continue doing your work. With that done, you come here. If we've done it correctly, load fruit should work now. Okay, that works now. The vegetable obviously won't work. The fruits work. So we then need to do justice to the Java bit as well. So we go here. So anytime you hit it, it will log. So you see this is the log. So if you hit it again, let's load fruits. The log is coming to the system. You can see somebody's trying to get fruits. It's coming. So now we go to Java. So we see the back one step, and then we see it to Java, and then we'll go in Java. So for Java, it's just Maven command to kind of set us on our way. And then I'm going to put the command on the system as well. So spring -boot, and I will do run, and then we'll specify the Java parameters. So we're going to say spring spring boot run argument. boot dot run argument. Argument. So we want to say that, okay, which is just basically the same thing we did with, kind of similar to this in a way. So we're specifying parameters that this should run with. So we want to specify that it should bind to local to the server address 00 as well on a different port though. So the way you do that with Java is almost the same. Just do dash server address, and then you say equals 0.0.0.0. And then you also say the port server, the port should be 8080. I think that's all you need to do. And then you want to run this in the background as well. If we've done it well, it should just work. Let's see. So this is downloading all this, like doing the requirements first, and maybe just simplifies everything for you. Okay. Oh, I think we may have killed the system. Okay, I hope it survives. Okay, I think it might be too much for it, but I hope it survives. Let's see. Okay, it does survive, I believe. Let's see it run. Yeah, it's struggling now because it's just a very small machine. It is struggling. It's running Python, it's running Java. That's why it's slow. Okay, finally it gets there in the end. So it's running. So that should take care of this as well now. If you load vegetables, you can see now that works. Okay, so, and then if you just want to kind of poke around just to see, so obviously this one is the back end. If you copy the IP address or you copy the public IP, public name, whichever one, I can't find the public name now. Whichever one comes to you. So get this. Let me find it. I like using public name. Okay, that one. Copy it and then you put it on a browser. You can just kind of poke around. Look at that. And remember to put HTTP in front. And then you can do the 9,000 fruits. Is it fruits? Fruits. Oh, is it invalid? 9,000. Okay, and then let's do fruits. Okay, or you can go to the Java endpoint, another kitchen. I think it's called vegetables. You can see that, and this is what this guy is feeding off. So the fruits and vegetables. Yeah, so this is a nice place to stop. So I'm gonna do an history of the command so I can share that on the channel with you, and I'm also going to update the README file, etc. But if you look at what we've done, it's just going to prepare you for the task for this week. So we're going to revisit this for this week. So what we've done is we've managed to get Apache and Python running. And somebody asked a great question in terms of availability zone, that everything is sort of, we not really taking that into cognizance. So what I want us to do for this week would be to basically this same thing. But in this case now, okay, so the Apache here should talk to the web server here. And the Apache here should talk to the web server. So, but you need to provision the system to kind of make it talk to. So in our case, let's not do a two system solution. Let's do a 4-system solution. 1, 2, 3, 4. What we're doing now is a 2-system solution. 1, 2, 3, 4, and then update the web server to point to the right back end. For people that are skilled and have gone far in DevOps, you can introduce load balancer. Okay, so this is going to be group A task. The group B guys are still kind of munching on the the project I gave them on Prometheus stroke web scraping stuff. So that's kind of a handful project to do. But for the group A guys, if you want to introduce the balancer, fine. But if you do not understand the balancer, don't worry. Just create a 4-node system, 2 web server, 2 app servers. And then this should point to this, and this should point to the, we are deploying this on them. So, but you would do 4 machines as opposed to 2 machines, which we've done on class. And try to make sure they are in different availability zones. And that's all you have to do. Obviously, you're going to end up with 2 web servers. So, and then you can kind of play with them. And if you're brave enough, you can add a load balancer. So you won't have to be using 2 different web endpoints. You could just use load balancer, and then that would basically direct traffic to either of the machine. Okay, Wiley, ask a question.
Thank you, sir. Just a quick one. When you copied the public DNS for the backend,
You need to speak up so I can hear you. I can barely hear you.
yeah, when you copied the public DNS for the backend machine, and pasted into the index.html file. Remember, on our end, we did not SSH into the repo. We did an HTTP kind of thing. So how do we now get to modify the HTML file when we did not SSH into the repo?
Oh, no. So obviously you need to copy the repo into your space, right? So this is my space. You won't be playing here. So you will do a fork into your repo, right? So everything you do has to be from your repo.
All right, okay.
So what I would do is you can take the release 2 and then play with it and use that. And then also if you want to update the README file to add the Java bit as well. Yeah, but obviously this has to go into your repo. That's a great question. So it won't not be from my repo. You copy my repo into your repo and then you can play with it. Yeah. Does that answer your question, man?
Yes, it does. Thank you.
Okay, cool. All right. Right. Kunle, any other? I mean, have I sort of answered your question we're going to ask, Kunle?
Yes, you
Okay.
have answered everything brilliantly. Thank you.
Fantastic. All right.
I can discuss. Thank you.
Thank you. All right. Excellent. Thank you, everyone. This is where I'm going to kind of stop. I wish you have a great week. If you have any questions or comments, feel free to drop on the channel. I will share this command with us and all the commands I use on the channel so we can leverage. Have a brilliant week. Thank you. Bye-bye.